This video is going to round off the work that we've done so far on gradient. So far we've been doing this on a square grid where you've been able to count the squares or measure the distances to work out the gradient. But this time we're going to move away from doing it on the picture and work out the gradient when all the things that you know are just 2 points. So I'm going to show you a few examples as to what I want you to do and achieve, and then you're going to have a go yourself. So first of all, I want the gradient of each of these lines. We've got 2 points on them, but no scale. So what we need to do is we need to draw on the picture a way to get the rise and the run to then work out the gradient, because if you remember, the gradient is the rise divided by the run. Okay, we need those two numbers. So what I'm going to do, I'm going to put those two things on the picture by drawing a triangle like we've seen before. So I'll do the rise in red and the run in blue. Okay, then the rise of this graph between these 2 points, well, I've got a y value over here where it starts, and I've got a y value up here at the end point, and I want to know what the difference is between them. So what I need to be looking for the rise is the difference between the y values. So what I'll do is I'll underline the y values in red, because they correspond to the rise. This y value down here is 5, and this y value up here is 11. The difference between them is 11 minus 5, which is 6. Okay, so the difference between there and there is 6. Along the ground, for the run of the line, the point A has an x value of 1, that's down here somewhere, and when I move across here, the new x value is 4. So just like normal, just like before, the run is the difference between the x values. Okay, so this value is going to be 4 minus 1, which is 3. Okay, so using those two values, I can then get the gradient. I can use this sum over here. So the gradient is 6 divided by 3, which is 2. Okay, so again, what I've done is I've looked at the y values and I've found the difference. I've taken the x values, which are in blue, and I found the difference, and then I've divided them. Okay, and that's to get the rise and the run. Let's do the second one. So again, I can draw this triangle on if I need to. I can go down to the x-axis down there, and then run is along there. Oops, let's make it blue. Okay, so let's do the rise first. So what are my y values? Okay, so I can find the difference. Well, the y values are 8 and 0. The difference between them is 8 minus 0, which is still just 8. For the run, we need to be looking at the x values, which are here. I'm going to put them in blue. And the change in the x values, the difference between them, is 6 minus 4, which is 2. Okay, and then dividing them again, the gradient is 8 divided by 2, which is 4. Okay, so those are my two gradients. This one's got gradient 2, this one's got gradient 4. Now what you want to be careful of is sometimes the line is going to go downhill. And if you've got a picture of your sketch of your line, you can figure out if your line needs a negative gradient if it goes downhill. If you don't have the picture, you need to be a bit more careful with how you do this method. Okay, so I'm going to show you a couple more examples where there's no picture and show you what to do in that case. All right, but first of all, I'm just going to write down what we did. So rather than writing rise over run, I'm going to show you how I got all those. So the gradient, you might want to write this down. It's the change in the y values, the difference in y, and that's divided by the change in the x values, okay, the difference between the x values. Okay, so this is like a new way to write the gradient if you've got those 2 points, okay? Find the difference, and divide them, okay? Now, these ones don't have pictures on, okay? And we're going to try and do it without using the picture. If you really need to and you want to plot these on some axes, you can do it initially, but try to get the hang of how to do it without the picture. So again, I want the gradient of the line that will pass through each of these two pairs of points. For the first one, we can do something similar. I want the change in the y. These are the y values. And what I'm going to do is I'm going to draw a subtraction arrow to show that I'm going to subtract this way around. Okay, if I take these numbers away, that's the change in the y. If I look at the x values, which is 3 and 1, I can find the difference again, but I've got to make sure that when I do my subtraction sum, I do it in the same direction that I've done the other subtraction sum. So if I take away from right to left in red, I'm going to take away from right to left in blue. Okay, so for my gradient sum, I've got change in y on the top, 10 minus 4. I've got change in x on the bottom, that's 3 minus 1. And if I work those things out, then the numerator is 6. The denominator is 3 minus 1, that's 2. So the gradient is 6 divided by 2, which is 3. Okay, what I might do, if you give me a second, I will copy this across so you've got it handy. Okay, there it is. Let's do the same for the second and third one. So again, we can look at the change in the y. That's these two numbers. And again, I'm going to subtract this way, right to left, because that makes it easy if I do a big number minus a small number. So then 12 minus 0 on the top. Change in x on the bottom, that's 3 take away 0. Again, I'm going to subtract in the same direction as I did it over here. And then 12 minus 0 is just 12, 3 minus 0 is just 3, 12 divided by 3 makes 4. So the gradient's 4. Okay, for the third example, this is where you need to be a bit more careful because there's a minus number hiding in here. Okay, if you want to use minus numbers, you've got to be really careful about how you do these takeaway sums. So finally, same idea. I'm going to look at the y values, 14 and minus 2. I'm going to subtract them this way round. So on the top of my fraction for the gradient, I'm going to have 14, and I'm going to subtract negative 2. Okay, so I'm taking away, it's a minus number, so I'm going to get a double negative here. Then on the bottom, that's a little bit easier, it's the change in x. I need to make sure I'm subtracting in the same direction. I'm going to subtract this way again. So 9 minus 5 is my denominator. If you simplify the top and the bottom, 14 minus minus 2, well, that makes a positive because there's a double negative next to each other. So that's actually 14 plus 2, which is 16. And on the bottom, 9 minus 5 is 4. Divide them and you get 4 again. Okay, so just be careful with using those negative numbers and always subtract in the same direction with your x's and your y's. Okay, now finally, these harder questions involve doing it backwards. And again, I'm going to copy the sum down to help you. If there's algebra in your coordinates and you're told the gradient, which in this case is 3, then you can do a sum that you would normally do, and that will help you work out what that missing value of c is. Okay, so I've got these 2 points. It's 5 minus 2, and then it's 8 something, and the something is written as a c. And the gradient between them is 3. Now, if I write this sum down for the gradient, that will give me something that will help me work out this value of c. So let's do the same thing that we would do normally, okay? I'm going to look at the y values. All right, we're going to take those away. That's the change in the y values. That's the difference. These are the x values. I can subtract those and find the difference as well. Again, I'm going to do it in the same direction each time. And then let's write that down. So c subtract negative 2 divided by, and then change in x is 8 minus 5. Okay, and that's written down. That's the sum that would work out the gradient, but actually we're told what the answer is. We're told what the gradient is, it's 3. So I'm going to make this sum equal to 3. Okay, and now what I've got is I've got an equation that's got my missing number in it that I can hopefully work out what it is. So let's do some simplifying. Let's take this fraction that we've got. I'm going to simplify where I can. I've got another minus minus like we had on the other page. C minus minus 2 is C plus 2. Let's make that simpler. And on the bottom of the fraction, 8 minus 5 is 3. So I can put it as just 3. And again, the answer to that sum equals 3 as well. Okay, now it's an equation. I need to do some balancing on both sides to help me get to this missing value. So using BIDMAS, the first thing to clear in this sum is the 3, because that C and the plus 2 are stuck together on that numerator. I need to clear the denominator first. So times both sides by 3. So what will happen there is that the divide by 3 is going to cancel out. So you've just got C plus 2 on the left-hand side. And if I do 3 times 3 on the right-hand side, that makes 9. This is what I've got now. If I want to work out the missing value, then you can clear away this plus 2 with a minus 2. So the next step to get the answer is minus 2 that side, minus 2 that side, and then C equals 7. Okay, so these ones are slightly harder. You need to do the same sum you do normally, but you write in your missing value, and then when you tidy up all of the algebra and work out all the sums and make them simpler, you can hopefully work out what the missing value is. Okay, so those are the 3 types of question I want you to do. If you have any questions on it, as always, you can always give me a shout and I'll get back to you on it. Okay, best of luck. Thank you.